My question is now, which type of data analysis and model is fit for evaluation of traffic data for major roads?
Okay, traffic data. Okay. Okay, that's a very nice question. Which kind of data set is fit for evaluation of traffic? Yeah. You see, there are a lot of, depending on what exactly you want to do, several work going on in this area. I remember one of my
Yes,
folks
sir.
that was co-supervising in somewhere in Africa sometime, was working on this kind of traffic data. See, there are different type of data you can use. However, we can start small. First of all, what do you want to do? It depends on your research question. You want to know the number of cars that will pass a particular road. This is the prediction you want to make. You want to predict the number of cars that will pass within an hour, or within, so that you'll be able to provide for advice for traffic police to come around and prevent accident. It could be traffic accident hotspot prediction. Want to predict the number of accidents that will happen in a particular area. We have some hotspots for accident. These data sets are available with the traffic police. Some country already digitalize it. Whatever the police caught or recorded in case of accident, they document it. The date, the time, what was responsible, the kind of driver. The information are there with them. If they are documented in computing, good. If it is even in paper, that's fine. You approach them, because get the ethical approval, explain to them what you want to use it for, and then they give you the data. You now see the data. Oh, okay. What can we do with it? I remember one of my past projects, undergraduate project, was to predict accident hotspots, where accident will be more in this particular location. And they were able to identify some hotspots that on Monday morning, so place, there will be too much accident there. Then they will send alert. The software will send alert to the police, traffic police, to go to that center that there will be more accident in so spots. Based on the data the police also provided earlier, they used in a training model, and then it was making the prediction. Then the police can go there and mount some roadblocks to prevent people from speeding to those points. Because one of the major causes of accident is overspeeding. When you speed to a very roundabout, this and that, nobody wants to wait for each other. But when you have a roadblock there, police are everywhere. Hey, you have to wait, irrespective of where you are coming from. Wait, you leave that place in a very simple manner. Thereby, because the essence of the prediction is we want to have an idea that will be a problem. We want to prevent the problem from happening. So prediction is not about you are a doomsday predictor. No, we are only predicting it so that we have an idea to prevent it from actually happening by advising necessary police authorities on what to do at a point in time. That's number one. So the data sometimes are very simple. Number of accident per spot, they categorize that city to spots. Spot A, spot B, spot 3, and they label them. Number of accidents that has ever happened there, what was the cause of the accident, how many people were involved, were there fatality, that is, do anyone die during the accident? That means you want to predict also fatality. After identifying the hotspot, another thing you can do in traffic-related data is you want to predict if the accident is going to take place, is there going to be any fatality, or is it going to be mild accident? Fatality or no fatality. That is another thing you may want to do in the traffic-related data. That is going to be a classification problem to be solved. A classification problem to be solved. And there are host of other analysis that you may do. Sometimes it's just to be able to predict the number of cars that will pass through a particular road at a point in time. At a particular time. So you'll be able to know what's the nature of the traffic, to be able to know what you can avoid, especially in crowded cities. We all know that. People staying maybe in Lagos and other big cities in the world, you may see, okay, you can have an idea. Your model will predict for you, oh, there's going to be traffic in so area. Then it will divert you. And that can, if people are data-driven decision-making oriented, it can prevent even a lot of hold up from happening. Now you are aware there's going to be hold up in a particular way because you already use your modeling app to predict for you. Then you can divert yourself. Meanwhile, there's another option, but it's a little bit further, by maybe 10, 20 minutes. To me, I prefer to take a further road than getting stuck in hold up. Because getting stuck in a kind of traffic, there are so many disadvantages. It's very risky. Anything can happen to any car. Some car, when they get stuck in the traffic, they can be heated up, anything could happen. The car could break down. The car is used to moving, the air is blowing and it's cooling itself as it moves. When you are stuck in traffic, everything, the heat start getting up. The AC may stop working, the fuel may stop. There are so many things. So personally, I prefer to take a longer route than to get stuck there. So if I get data-driven informed, this is what Google Map is doing for us. If you use the Google Map, you pick a Google Map, you do it, they are using traffic analysis. It's not they are there physically. They already monitor what is going on. Of course, they also use the satellite technology. So you can be able to do a lot of prediction, having an idea what may happen in those systems. I would recommend for you, because of time, there are so many data you can check out. You can go to you can private chat me, or I'll put it on the forum later. We have a lot of free data set online. You can also Google it, search out for it, a lot of traffic data. Where you start is, first of all, look for the kind of work you want to do. Go online, get the data first. The one someone used before, analyze it, see it. There are different types of data. There are ones that are taking pictures based on picture, image-based traffic data. But I usually advise people just starting to go for numerical data, categorical data, so that you can start simple. Later, you can then go for that of imaging, video, and the likes, because those ones need a lot of processing space and also processing unit. A lot of laptop may not be able to process very huge, and even sensible images or videos. So I encourage, get CSV data. We have a lot of one available there in CSV format. CSV is like Excel, a special type of Excel format that you can use, and it's compatible with any platform you want to run machine learning model. That's the advantage of CSV. I usually encourage people to start using that. So we have a lot of data set, road traffic. We have several governments already mandated their traffic unit to have the data online. So you can just download those data, start looking at them, and then see which type that relate to your research question or what you want to work with. But my advice, start with very simple data set that you can relate with easily. So, and then you can private chat if you face problem getting different type of data set. You can private chat me later, or our coordinator, for personalized guide. I hope that answers your question. Surveyor Olushola Roland. And I know as a surveyor also, you may also need even geospatial data that has to do with
data from the traffic management.
Yeah.
Yes. So my master's, and that's my project. Thank you very much, sir.
Okay. You are welcome. So you can relate if you have any further questions. Don't worry, feel free to relate. Okay. You are highly welcome.
Thank
you. Yeah.
Yes.
Yeah. 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 Okay, I think there's another hand up. Who is that person? Please, we are run out of time. Okay, that's the only question we have for the day. Okay. Okay. Okay, that's fine. So thank you very much, all. That's what we are going to have for the day. Again, we encourage us. Maybe there's a question there. Okay, I have a question here. Okay. Good morning. Okay. Which type of analysis and model is fit for evaluation of traffic data for major roads? Okay, by type of analysis, if you mean, where mostly we use combined form of analytics. I think, okay, your question now is clearer. We use different type of analytics. Sometimes you may use descriptive and predictive. It's very common. In fact, descriptive is almost compulsory in any analysis you want to do. Well, you need to understand your past before you can think of future. So descriptive analysis, the first level, is always almost compulsory. You have to do the mean, median, standard deviation of your data, plot the graphs, how many male and female, what is data distribution. You need to understand your data. So that is descriptive. It's almost compulsory in every work. If you want to publish work, you need to describe your data, where you got the data from. How many samples do you have in the data? How many samples do you have? How many variables do you have in the data? The total number of samples. So descriptive is almost compulsory. The next is predictive. Diagnostic sometimes is optional. You want to know why the data is like this. You may run diagnostic, but usually it's optional. But when I teach students, I always say descriptive and predictive is compulsory. You must describe your data and you must also predict something. Predict what's going to happen about the data in the future. How many student enrollment are we going to have in the school? Which student may drop out of the university? That is predictive. The prescriptive, we talk about later, that is also specialized. It's like optimization. You want to achieve a particular characteristics in your product. What can I do to achieve that characteristics? Prescriptive analytics will do it for you. You need to do this, so that you can achieve this. We want to achieve a particular number of student intake and also graduate in a particular frame of time. Then prescriptive analytics will run, it's like optimization, and then tell us, do this. If you do this, your intake is going to be stable, your output also is going to be stable. Hope that answered that. Another questioner say, good morning. A version of Design Expert was used to generate runs for experiment. Can another version be used to analyze the result of the runs? It depends on the way they generate it, okay? I always like to use real-life data set. When you generate data, it depends. Some places, they don't have data set, they generate data, but this may not be real life. When you go to real life, it may not work. So that is why I always recommend to people, use data that has been used online. It could be from another country. The real life data that has been used, published with, you can then use it. Maybe they got 85%. You try to use it and get like 95 or more, better accuracy, better predictive outcome. And then while you start gathering your own data in your locality, because you are using real life data, even though it's another country, it is better than when you generate a data. But sometimes I know in some area you have to generate data. That is fine. If you generate data runs for experiment, it's better to generate more. Then divide that data you generate into two, training set and testing set. Then you see what is your result. But when you generate data and you generate another one separately, if the characteristics of your generation is different, the model may not be able to extrapolate to it. But we don't say it's not possible. You can give it a try. But we can't guarantee that you're going to get a good result if the data set is totally different from the other one. And that's why we have training. When we train, you must make sure the data set you are training is representative of everybody. For example, if I train, I want to train to identify criminals. You don't train one tribe to be the criminal. All the criminal samples, they're from one tribe. All the good people, they're from another tribe. When you use such a data, you're already trained to be biased. So your model will always predict a particular tribe as a criminal, while exonerating another tribe to not be a criminal, even if they are criminals. So this is the problem of bias. It could be a serious issue. So if your data set is representative, so whenever you generate other data, let them also be representative as much as possible. The training is the most important. If you train data with different people from different tribes, both the good ones and the bad ones, then later, any tribe that comes, you can recognize them without being biased. I hope that clarifies. So it's always good for the data to be similar. Heterogeneous data is one of the very challenging areas to model. Another thing you can do is, if you generate using a particular pattern A, you generate another data divide it into two, training there, divide this also to training and testing, merge the training from two sides, and let the testing and testing also testing from the two sides. So the training is being done using the generated data 1 and the generated data B. And then you can test it on the two also. By so doing, you can get better result than when you train on one generation and you are testing on another generation, because the characteristics of those generations may be totally different. This is to avoid being biased. But you can give it a try. If it doesn't work, then you can follow the advice. Good morning. What about prevention of electrical accidents and electrocution? Yeah, you want to prevent electrical accident and electrocution. Depending on the data set, you are going to do descriptive analysis first. You bring your data on board, let us analyze it. We do descriptive analysis. Later, we're going to talk more about descriptive analysis. We'll talk about examples and how we can do that. We do a lot of analysis. Even for some work, some company don't need any predictive. They only need descriptive. They want to see the data, what is happening. This is what is happening in my company. Maybe a little bit of diagnostic. Why is it happening like this? That's what some manager needs, some company needs, and they'll be fine. Data is telling them exactly what is going on and what is responsible. They can figure it out. You want to go further, then you go forward. That is inside. You want what is going on inside. Or even futuristic. What will happen in future? So once you get the data, then you can run predictive analysis. It's very common. You want to be able to predict that it's going to be electrical accident before it happens. Yeah, so that you can save life. That'll be a very nice work, but depending on the kind of data you have. And I want to believe electricity company is supposed to document cases of electrical accidents. What was responsible for it? Just get those data set, get the approval, the ethical approval to use the data set. They don't need to put name of those people, and we call it anonymous data or anonymized data. No name, no address of those people, just the incident alone. Then you can bring the data up. You can do descriptive analysis. You can do predictive analysis. You may even run diagnostic analysis. You want to understand what is responsible for the accident. Is it ignorance? Is it because of the cables are exposed? You want to be able to know what could be, or it's just, sometimes it could just be negligence. For example, I witnessed a scene of electrical company staff came to a village, climbed the pole. I think they were on official duty to do some work. There was no electricity at that point in time. Unfortunately, as this guy was working, electricity came. It was a very, very horrible sight. The guy fell from, though we thank God he survived it. He fell from the top. But my question was, were the people who are going to release, it came from the office where they control the electricity. Were they not aware he was going to do some work outside? That is negligence. You see, a life could have been lost. So once you have data set that took care of this kind of situation, then we can analyze diagnostic, what's responsible, descriptive, and even predictive. So that you have idea of it may happen, and then you can then prevent it from happening. From Olaniyan Taiwo, good morning, sir. Is it possible when carrying out a land use analysis to edit the algorithm when you are not satisfied with the classification tool you are using on Akamai software? Well, it depends on the software you are using. Some software, they are like built-in. They don't allow you to play with some things there. That's why I don't recommend such things. So you can use Simple Weka, get your data set, use Simple Weka to build your system. Then you can then take it to that algorithm. Ordinarily, they should allow you to edit what we don't edit the algorithm, but you edit the hyperparameter of the algorithms. Hyperparameters. For example, k-nearest neighbor is the simplest algorithm. You can check our video. You see k-nearest neighbor. It's one of a very simple algorithm. The principle is show me your friend. I'll tell you the kind of person you are. If 5 of your friends are corrupt, then you are out of 7 friends, 5 are corrupt. They are being convicted of corruption. Only 2 are free. Then we are going to categorize it as being corrupt. So that's the principle of that algorithm. Show me your friend. I'll tell you the kind of person you are. So we have to change the k, number of k nearest number. We try 1, we try 3, we try 5, we try 7. So this is what we can change in your algorithm. You change different upper parameters of the algorithms. However, once you see all the possibility, usually you see the result as you are changing it, The result keep increasing. It get to a point, it start going down. Then you are going to pick this place as the optimal value. Maybe at that point, K is equal to 7. You can draw a cutting. At that point, you may not be getting what you needed. It means that algorithm is not good for your data. You have to use another algorithm. You change another algorithm again, decision tree, machine learning, and host of others. But there's some software, depending on the software you are referring to, they don't have machine learning integrated. They are just using some software. It's just programming concept, simple mathematics. You may need to graduate to using machine learning. Just like when people were using statistics in the past, and also in economics, they use econometric. But I've seen now people who are now using machine learning, and they compare their result with the previous experience in econometric and statistics. And it is always, wow, they got better result than what they were getting before. So you may also want to try out machine learning and then compare with what your software used to produce. That is a research work on its own. You can compare and then get people informed of the need for them to also try out machine learning and see how they can get their work better. Okay. I think my professor is raising hand. So, okay, those are the questions in the chat. Thank you very much all for the feedback. Now we take Prof before we call it a day. Professor Shola Olorunfemi, you have the floor, sir. Prof, are you there?
Yeah, I'm here.
Wonderful.
Hello.
Hello, sir. We are hearing you, sir. You are welcome.
Yeah. I'm very happy joining you this morning.
Thank you very much, Prof.
Yes, and towards the end of your explanation, you mentioned econometrics. So I want to learn more because the example you've been given since has to do with those of you in science, deep science.
Okay.
So I probably because today happens to be the first time I will join. So I want to see how it will be very good for me to be part of your students here.
Thank you very much, Prof. We are very happy to have you. That is
Thank you, sir.
Olorunfemi, the present postgraduate dean of Adekunle University.
Yes, sir.
So you are highly welcome.
Yes, sir.
So hopefully that's also going to be the motivation for our students, postgraduate students, and undergraduate alike.
Thank you, sir.
If the old dean of graduate school, the deans of deans, can take the time to attend this kind of section, that also will send message to people. Like I said, we can no longer ignore AI. For sure, Prof, you have a lot of things we can do in the area of social sciences, economics, every fields of life, actually. Yeah. And I think today also we have Dr. Salami. If I'm not mistaken, I saw him in the beginning. Are you still there? Dr. Salami, he is one of the persons from economics department. He joined us in 2021, I think. He has been very consistent, and today he defended his PhD in economics recently, and he used machine learning and AI a lot in his work, in his thesis. He achieved huge outcomes. He spoke with us last 3 weeks. I saw him today in the beginning. So I can assure you, with that feedback from Dr. Salami, so from Kogi State University, I believe, so there's so many things we can do together. You can gain your PhD student, postgraduate student, encourage them also to subscribe. They are going to be posting some videos that we can check out at the very early stage of our learning that is good to them.
Thank you, sir. I'll do that.
So you're highly welcome, Prof.
Thank you, my brother. God bless you.
Welcome every other person also that joined us recently. So together, we see how far we can also benefit ourselves. Thank you for the day, and I've taken so much of our time. We usually